Okay, so in this video we're going to be introducing you to the fundamental ideas of geometry, and we're going to be starting off by teaching you the three undefined terms. And so what do I mean by undefined terms? What I mean is that when we talk about undefined terms, we cannot define them mathematically without using terms that themselves need definition. And so the reason why I'm teaching you these three undefined terms is that we're going to need them to define other things. For example, if you want to talk about angles, you can't talk about angles without knowing about rays, and you cannot talk about rays without knowing about lines and points, right? And so, as I was saying before I was rudely interrupted by the dog, the three undefined terms goes as follows. They go point, so point, and then they go lines, and then plane. And so what do these all mean? Well, points, I'm pretty sure you've heard of this term, but here's a trick. They don't actually have a size. They just represent location. So in that case, they have no dimensions. And lines, on the other hand, they do have dimensions because they have length. And in that case, they're one-dimensional. And planes, they're two-dimensional. They have length and width, but no thickness. And of course, you're probably gonna be confused right now. And so I'm gonna go and give you some examples. So number one here, we're going to be talking about points. So let me switch the color and go to this color, okay? Alright, so here's an average example of a point. This is an example, of course. Actual points are infinitely smaller than this because they represent no size, or they have no size, actually. So let's call this J. And how might we write this? Well, all we have to do is write down a capital letter J. It's pretty simple, huh? Right? Okay, this time we're going to be talking about lines. And lines, we need to have a bit of knowledge from our points, because lines are made of points that extend forever. So you might see 2 points here, and let's connect these with an arrow. Of course, they're going to be much straighter than this, your average line, but I'm doing this on a mouse. So, all right, let's call these points J, or actually I. We've already used J. I and C, right? And the way we write this down, the way we say this, we can say it is line IC, we can write that down, or we can say, we can have AC, and on top of that we have a line, little line. And what this says is that we're going to keep having points along this line forever, into infinity, right? Okay, next we're going to be talking about planes. Planes are a little bit more trickier to understand. So here's an average example of a plane. And planes, like I said earlier, they're two-dimensional. They only have length and width. They have no thickness. To describe that, I'll give you an example of a 3D object. We can say a cube or some other type of 3D solid. I'm not going to attempt to draw it because I'm going to fail. But you can see that there is actual, thickness. I don't know how to describe it, but we're going to have cubic units. We can calculate the volume of it, but here we can only say that it does not. So in planes, we're going to have an infinitely small thickness, right? It doesn't exist. Okay, so let's talk about two new terms before I start out with a clean slide. Okay, so we're going to be talking about collinear and coplanar points. Okay, let's start off with coplanar. And so I'm going to reuse this old plane here, which doesn't look much like a plane at all because it's not straight and stuff. And here's our plane that we're going to be reusing, and then I'm going to give you 3 coplanar points. I'm not going to name them, alright? But these 3 points are collinear. Let's say these are J, K, and L, then we can say that points J, K, and L are coplanar because they exist within the same plane. To make this easy, let's talk about, if you know a little bit of Spanish, you know that co, it sounds a little bit like con, which in Spanish means width, of course. And I'm sure there are other variations of it in other Romance languages, but let's stick with Spanish now. So you can remember it like that. Co. Alright, so what about linear, collinear? Collinear is the same logic, it's width, in the same line. Co meaning width, linear meaning line, same line. So we can talk about 3 collinear points, J, I, A. And the way that they're collinear is that they all are part of the same line, right? So if I were to make another line, then I would have, say, A and B, and those 2 points would of course be collinear as well. Alright, so let's start with a new slide. So let's talk about 2 terms that we're going to have knowledge of our 3 undefined terms to, well, describe and define. Well, line segments, they're just composed of 2 endpoints, right? We're going to have an endpoint here and an endpoint here, and we're going to connect it with a straight line. And we can call these endpoints point J and point K. I've been using those 2 letters a lot, so in the next examples, I'm going to use different letters. And the way we can say this, we can describe these points as being line segment JK, or even better, we can call this JK, and we're just going to have a little straight line thingy-mabob there, with no arrows, of course, to signify that it does not extend forever. It is definite. It is not indefinitely extending. And let me give you another example. We can have something like this. Oh, bad line. Something like this. Even worse of a line. And we can have C and E. Point C and E. And do you remember how do we find these? We could call this CE with a straight line without arrows, right? And I'm going to be telling you right now how you can measure these things. So to measure them, we have 2 ways we can say how we can measure them, like 2 different notations of measuring them, I should say. Measure. Alright? The first way is probably the easiest way, or the most simplest way how you can write it, is just to say the 2 endpoints. So in this case, if we were to say CE, we're going to talk about this one. And so we were to say CE is equal to, let's give an arbitrary number, say 2. It's equal to 2 and an arbitrary unit, say centimeters. Right, 2 centimeters. And the other way we can write this, I'll do this in a different color for emphasis, is that we can have an M, a script lowercase m, and then we're going to have our line segment notation, which is a CE with a line over it. Right? And we can say that this is equal to 2 centimeters as well. And if you're wondering what's the difference, well, there's a difference, to the way you say it, but the values are the exact same. So in this first example here, with the neon green, we can say that the distance between endpoints C and E is equal to 2 centimeters. But in this case, we can say that the measure of segment CE is equal to 2 centimeters. Same thing, but different ways of saying it. Now, in this case, we're going to be talking about rays, and we'll have one more thing to talk about in this lecture. So stay tuned, please. So we're going to have a point. Losing my voice. A point there, and a line, or kind of a part of a line, a segment of a line. That isn't a good word. A part of a line is better. And we're going to have, what should we call our endpoint? Let's call it D, and let's call it an arbitrary point on this ray, O. D-O, Doctor of Osteopathic Medicine. Okay, nice joke. Alright. Well, what we're going to do here, I'm going to tell you what a ray is. I think I've already said it to you, but I'll say it to you again. We're going to have a point on one end and an infinitely extending number of points on the other end. So basically, you can use the same notation if you're going to see the pattern. We're going to use the same notation kind of like this, but instead of a line segment on top, we're going to have a ray on top. So let's write down DO, but we're going to write down a little ray on top. And we can also write this OD, right? Right? So, either way it'll still work. And there's one more thing I want to talk about. Not a good shade of black. The one more thing I want to talk about is the idea of midpoints. And midpoints, they're saying, like, in the middle of a line segment, pencil tool. So let's draw this arbitrary line segment. Not very straight. So a little better. So in the middle of this line segment, what's the point that falls directly, like perfectly in the middle? And we're going to go into more detail in the next lecture, but I'm going to give you the idea of what a midpoint is, so we can define it and use a formula in the next lecture. And so what it is, it's saying there's a point here that's directly in the middle, and we have to find that using the midpoint formula. And I believe that's it for this lecture. I hope you stay tuned.